Rational functions is Unit 8 of the course Applied Algebra or APA. Objective number 1. Determine the domain of a rational function. Example number 1. Find the domain of f of x equals 3 over x plus 4. Take note that rational functions cannot have a denominator equal to 0. So to find the domain of this function, we are going to find the value of x that will make the denominator 0 and exclude it from our domain. To do that, we are going to equate the denominator to 0. So we have x plus 4 equals 0. Subtracting 4 from both sides, we have x equals negative 4. So therefore, our domain is all real numbers except negative 4. Example number 2. Find the domain of f of x equals x plus 1 over x squared plus 4x minus 12. Again, the denominator of rational functions cannot be 0. So we are going to find the values of x here that will make the denominator 0 and exclude them from our domain. To do that, we are going to equate the denominator to 0 and solve for x. So that's x squared plus 4x minus 12 equals 0. X squared plus 4x minus 12 is factorable, and the factors are the quantity x plus 6 times the quantity x minus 2. Equating both factors to 0, we have x plus 6 equals 0 and x minus 2 equals 0. So here, x equals negative 6, and also in our second equation, x equals 2. So our domain is all real numbers except negative 6 and 2. Objective number 2. Identify the vertical and horizontal asymptotes of a rational function. Example number 3. Give the vertical and horizontal asymptotes of the graph of f of x equals x plus 1 over x plus 2. To find the vertical asymptote, we will just equate the denominator to 0 and solve for x. So it's x plus 2 equals 0. Subtracting 2 from both sides, x equals negative 2. So our asymptote is the line whose equation is x equals negative 2. For our horizontal asymptote, we are going to look at the degree of the numerator and the denominator. Here, the degree of the numerator or the highest exponent is 1, and then the degree of the denominator is also 1. If the degree of the numerator is equal to the degree of the denominator, our equation is y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. So in this case, it's 1 over 1. So it's just y equals 1. Example number 4. Give the vertical and horizontal asymptotes of the graph of f of x equals 2x plus 1 over x squared minus 5x minus 14. Again, to find the vertical asymptotes, we will just equate the denominator to 0 and solve for x. So it's x squared minus 5x minus 14 equals 0. And x squared minus 5x minus 14 is factorable. So the factors are the quantity x plus 2 and the quantity x minus 7. So equating both factors to 0, we have x plus 2 equals 0, and then x minus 7 equals 0. Then solving for x on our first equation, it's x equals negative 2, and solving for x also on our second equation, x equals 7. So these are the vertical asymptotes. The line x equals negative 2 and the line x equals 7. Now for our horizontal asymptote, we are going to look at the degree of the numerator and the degree of the denominator. So the degree of the numerator is 1 and the degree of the denominator is 2. So the degree of the numerator is less than the degree of the denominator. So if that would be the case, our horizontal asymptote is just y equals 0. Objective number 3, solve applied problems involving rational functions. Example number 5, Ahmed traveled 80 kilometers to Abqaiq for 1 hour. However, he spent 3 hours for his return trip. What was Ahmed's average speed during the entire trip? The formula in finding the average speed is total distance traveled divided by total time spent. Going to Abqaiq is 80 kilometers. Then the return trip is also 80 kilometers over time spent going to Abqaiq is 1 hour, and the return trip is 3 hours. So we have 80 plus 80 over 1 plus 3. So that's 160 over 4. And 160 divided by 4 is 40. So the answer is 40 kilometers per hour. Thanks for watching, guys. This is Teacher Rejil. Keep safe.